Okay, so what is well test analysis? Well, first off, it has different names. It is called well test analysis, well test interpretation, partial tangent analysis, PTA, PBU and PFO interpretation. Basically, what we have is we measure the rate at surface under stable production, and we can measure the rate via different methods. For example, with the test separator meter, an orifice plate for the gas, an MPFM, multi-phase flow meter. And then you slam shut the well with a surface or Danol valve for a finite time interval. So for a producer, if you measure the pressure at Danol, during production, pressure is going to decrease like this. So this is also called drawdown. And during shut-in, pressure is going to go up like this. And this defines the pressure buildup, or PBU. For an injector, during shut-in, pressure is going to decrease this way, and this is called pressure fall-off, or PFO test. So we've got different types of tests. We've got PBU, PFO for an injector, DST, so this is in general with the rig and some temporary completion. And probably during DST, you're going to shut the well Danol with a Danol valve. You've got extended well test as well. So you leave the well shut in for a longer amount of time to see further away in the reservoir. You got interference test to test for connectivity, mini frac and PFO before and after frac treatment, for example, and etc. So when you analyze a PBU or PFO, you're going to get some information about the flow behavior around the wellbore, well productivity and reservoir performance. And what is interesting, and we're going to have a look at this a bit later, is that you're going to get this information over a large scale of investigation. So now we are talking about kilometers or hundreds to thousands of feet. Okay, so why do we test wells? And in particular for exploration and appraisal wells, and in some cases, some pre-drill wells during development. I add this condition because you may have a pre-drill well and you may not connect it to your production facilities for, let's say, a couple of months. So in some cases when, for example, you've got a time delay more than 3 months, it's probably better to get a rig and try to clean up the well, reduce the damage, and do 1 or 2 PBUs. So in this context, the flowing period is going to give you confirmation of discovery and productivity. You will be able to clean up the well and to measure the rate. So via meters in the test separator and in some cases multi-phase flow meter. You can take large volume fluid sample and you can do that Danol via samplers, and at the same time you can take fluid samples at surface in the test separator. You can test as well for sound production. I've seen that in some few cases. So here at the bottom left, I've shown you sort of standard well test in the exploration appraisal context. So first we will have a cleanup, which lasts in some cases between 10 to 24 hours. The first PBU, then in some case a flow after flow test, a main flow period, and a second PBU. In general, it's better to have 2 PBUs so that you can QC the response and you can investigate for deconvolution. Deconvolution is a new tool and we're going to see this later. So on the shut-in period, you're going to get some information about the well and the reservoir performance. So the skin, KH, permeability times net thickness, initial pressure, heterogeneity in the reservoir, and by that I mean, for example, any change in reservoir properties, and the presence of boundaries. You're going to get some information on reservoir connectivity and proven volume. So for example, with a test, you're going to see a minimum connected volume to your well. As I said before, the flow behavior around the wellbore, and what is very interesting is that you've got a large scale of investigation. So kilometers, thousands of feet. What we need to know is that there is no alternative method to calculate the skin, permeability, other reservoir parameters over a large scale of investigation. There is no alternative to get large volume fluid sample and to get information on connectivity over large volumes. So why do we test wells in exploration and appraisal? Well, to avoid future production surprise and to appraise more with less number of wells. So instead of drilling a well a kilometer away, you can just test it and you will have a large scale of investigation. During production, and for a new well, for example, following the initial production startup, what you will need to do is to get a measurement with a production flow test and then get a baseline initial shut-in. So that's going to give you the initial performance. So the skin permeability, connectivity, productivity index. And it's probably better to do that in the first to second week of startup. You can also assess completion performance, and you can discuss that in a post-well review. During production, well test analysis is a very powerful surveillance and diagnostic tool. So you're going to end up like on this plot with periodic tests, and probably more than 95% of it is going to be opportunistic. And that's going to help you to calculate the reservoir pressure for each PBU, to monitor the performance over time. In some cases, you can detect waterfront and predict water breakthrough a couple of months in advance. And you can also support the lab-derived relative permeability curves. You can monitor your water flow process or any other recovery process. You can understand the causes of performance deviation. That is quite interesting because then you can prepare, you can get a better tailored well intervention. You can assess well intervention with a pre and post test, and you can also quality control your rate measurement. Here I have plotted the gauge pressure and the rate versus time. So well test analysis is the process of exploring these pressure data with special well test tools and techniques. It is a process of recovering the well and reservoir information out of your measured pressure and the rate. It is a non-unique process, and that leads to a range of solutions. And this is why you need a multidiscipline approach. You need to try to reduce the range of solutions, and you can use the seismic, you can use the cross-section, the log, and PLT, for example, to try to bring more constraints. Okay, well test support. Well, you can go to testwells.com. You will have more and more training course with the basics in well test analysis if you want to push this further, basics in surveillance, and as well in the well test group you will have access to some newsletter, some new presentations, and audio conference. All right, thanks very much for your attention.